Find the equation of the circle with a centre 1, 4 and a radius length of 5. So our formula for the equation of a circle that does not have a centre at 0, 0 is x minus h squared plus y minus k squared is equal to r squared. So what we're going to do is label our point h and k. So we substitute into our formula. So we swap the h for 1 and we swap the k for minus 4. So we end up with y minus minus 4 squared. And we swap the radius, which is r, for 5. So we have 5 squared. So we have x minus 1 squared, just stays as it is. And y minus minus 4 squared becomes y plus 4 squared. And that's still equal to 5 squared. And the only other thing to do is just to change the 5 squared to 25. So x minus 1 squared plus y plus 4 squared is equal to 25 is the equation of the circle. In our next example, we want to find the centre and the radius length of the circle x plus 2 squared plus y minus 8 squared is equal to 49. So our given equation is x plus 2 squared plus y minus 8 squared is equal to 49. And the general equation, so basically our formula that's given to us in our formula books, is x minus h squared plus y minus k squared is equal to r squared. So if we compare the two, minus h is going to be equal to 2. So minus h is equal to plus 2. So if minus h is equal to plus 2, then h is going to be equal to minus 2. And then if we compare our k value, we have minus 8 is equal to minus k. So we have minus k is equal to minus 8. Therefore, k is going to be equal to plus 8. And lastly, we have 49 is equal to r squared. So we have r squared is equal to 49. So r is going to be equal to the square root of 49. And the square root of 49 is 7, so r is equal to 7. And remember, our h always represents the x value of our coordinate, of our centre of our circle. And the k always represents the y value of the centre of the circle. So the centre of our circle is minus 2, 8. So minus 2, 8. So an x value of minus 2, or you could call it a h value, and a y value of 8, or you could call it a k value. And the radius length is 7, because r is equal to 7. So in the first example, we were asked to find the equation given the centre and the radius. And in the second question, we are asked to find the centre and the radius given the equation. The circle shown has a diameter with endpoints 2 minus 3 and 6 minus 8. So here's our circle and here's our diameter. We want to find the centre of the circle. So we can do this by getting the midpoint between these 2 points using our midpoint formula. That will give us the centre of the circle. Find the radius length of the circle. We can do this by using the distance formula from our formula book. We can either get the distance between these 2 points and divide it by 2 to get the radius, or once we've found the centre of the circle from part 1, we can use one of the other endpoints to find the radius using the distance formula. In part 3, find the equation of a circle. So for the equation of the circle, we need the centre point, which we will have from part 1, and we need the radius length, which we will have from part 2, and we put it into the equation of the circle formula. So part 1, find the centre of the circle. So the centre of the circle is the midpoint of the endpoints of the diameter. So we need to find the midpoint of 2 minus 3 and 6 minus 8. So we're going to use our midpoint formula, which is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. we're going to label our end points of our diameter as x1, y1, x2, y2. Subbing into the formula, we swap x1 for 2, bring down the plus, swap x2 for 6, that's all divided by 2. We swap y1 for minus 3, plus y2, which is minus 8, all divided by 2. 2 plus 6 is 8, and 8 divided by 2 is 4. Minus 3 minus 8 is minus 11, and minus 11 over 2 just stays as it is. So the centre of our circle is 4 minus 11 over 2. Part 2, find the radius length of the circle. The radius of the circle is the distance from an end point of a diameter to the centre of the circle. So we're going to use our distance formula from our formula book, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to choose one of our end points of the diameter. We're going to go with 2 minus 3, and the centre, which we got from part 1, which is 4 minus 11 over 2. So we're going to label our points as x1, y1, x2, y2, and substitute into our formula. So bring down the big square root, swap the x2 for 4, bring down the minus, swap the x1 for 2, squared plus, swap the y2 for minus 11 over 2, and then we have minus y1, and y1 is minus 3, so we actually have minus minus 3, and minus minus 3 gives us plus 3, so that's why we have plus 3 in there, and all that's squared. So then 4 minus 2 squared gives us 4, and minus 11 over 2 plus 3 squared gives us 25 over 4, and 4 plus 25 over 4 is 41 over 4, and we can leave the square root as it is. We're going to leave it in square root form or surd form. So part 3, find the equation of the circle. So our equation formula for a circle that does not have a centre at 0, 0 is x minus h squared plus y minus k squared is equal to r squared, where r represents the radius and the h and the k represent the coordinates of the centre point of the circle. So we got our centre point of our circle to be 4 minus 11 over 2, so we label the 4 as h and the minus 11 over 2 as k, and we got our radius to be root 41 over 4. So subbing into our formula, we bring down the x and the minus, we swap the h for 4, and that's squared, bring down the plus, bring down the y, and then minus k squared is going to be minus minus 11 over 2, and minus minus 11 over 2 is plus 11 over 2, so that's where the plus comes from, plus 11 over 2 squared, and this is equal to r squared. So remember, we got our radius to be root 41 over 4, so it's going to be root 41 over 4 squared, but the root and the squared will cancel out, leaving what's under the root, which is 41 over 4. So we have 41 over 4 on the right of our equals. So this is our equation of our circle.